Okay, let us continue the second part of today's class. Okay, integrating both sides of equation 6, okay, with respect to h we get. Okay, we get the exponential of minus h squared is equal to the minus in integration of 2h times exponential minus h squared dh. Okay, therefore, okay, therefore equation 5, okay, this equation is equal to the minus. Okay, we can put move minus to the left hand side of equation 7. Minus exponential of minus h squared, and the lower limit is 0, and the upper limit is sigma times the square root of x over p. Okay, and it is equal to 1 minus exponential of minus x times sigma squared over p for x being equal greater than or equal to 0. Okay, finally, the PDF of row I is okay, f row I of x is the differentiation of this equation. That is the CDF 1 minus exponential of minus x times sigma squared over p with respect to x. Okay, so it is equal to a minus exponential of minus x sigma squared over p, and according to the chain rule, times minus sigma squared over p. Okay, so it is equal to, we can cancel this minus sign and this minus sign, and move this term in front of the exponential function. So this equation is equal to sigma squared over p times exponential of minus x sigma squared over p for x being greater than or equal to 0. Okay, so which shows that row I is exponentially distributed. Okay, so this completes our solution. Okay, do you have any questions? Okay, if you do not any questions, let us go back to the slides. Okay, next page. Therefore, the probability density function PDF of row I is given by f of row I is equal to 1 over row bar I times exponential minus row I over row bar I when row I is greater than or equal to 0. And f of rho I is equal to 0 when rho I is smaller than 0, where rho bar I is the mean value of the SNR on the ith diversity channel. If the diversity channels are independent, it follows that, when the diversity channels are independent, we can see that rho I from I being equal to 1 to ND, where ND is the diversity order, are independent random variables. So back to equation 1.9. So for this term, this is also a random variable. So for I is equal to 1 to ND, these random variables are also independent. So the expectation of product of these random variables, can be rewritten as the product of the expectation of this random variable. So then now we want to calculate the expectation. We can write an integration from 0 to infinity. And the PDF of rho I is 1 over rho bar I exponential minus rho I over rho bar I times exponential minus beta times rho I over sine square of theta d rho I. Then we can see that there is a common term here. Here is a minus rho I. Here is also a minus rho I. So we can combine these two exponential functions, like this, and move the common term minus rho I in front of the exponent. And the remaining term is, for the first exponential function, the remaining term is 1 over rho bar I. So there is a 1 over rho bar I here. And the remaining term in the second exponential function is equal to beta over sine square of theta. So here is the plus beta over sine square of theta. And the last step follows from performing simple integration. From this step, to this step, we can evaluate this integration, and we will have this term, sine square of theta over sine square theta plus beta times rho bar I. How do we get this equation from this integration? Please see the handout. On the handout, please turn to page 135. Problem 1. Derive the last line in equation 1.11. Answer, please see the blackboard. Because I do not have a blackboard here, so I use the Microsoft Word instead. This is problem 1. Of the on page 135 in chapter 1. Derive the last line in equation 1.11. Okay, solution from the first line on page 135. We know that okay, P bar B, which is the average bit error probability, is equal to 2 alpha over pi times the integration from 0 to pi over 2, and the product from I being equal to 1 to ND. Okay, and in the bracket, it is an integration. Okay, integration from 0 to infinity. 1 over rho bar I exponential minus rho I times 1 over rho bar I plus beta over sine square of theta d rho I d theta. Okay. Okay, for the notational simplicity, let let C being equal to 1 over rho bar I plus beta over sine square theta. Then the inner integration in equation 1 becomes okay. Okay, I is defined as the inner integration in equation 1. Okay, that is this integration. So it is equal to the integration from 0 to infinity, 1 over rho bar I and exponential of minus C rho I d rho I. Okay, because 1 over rho bar I is a constant, so we can move this out of the integration, okay, like this. So in the integration, it remains the exponential of minus C rho I d rho I. So it is equal to 1 over rho bar I, okay, then times Okay, 1 over minus C. Okay, and times exponential of minus C times rho I. The lower limit is 0 and the upper limit is infinity. Okay, so it is equal to 1 over rho bar I times 1 over minus C. Okay, so this is equal to limit rho I approaches. Oh, sorry. It should be right arrow. Okay, I need to insert two symbols here. Okay, the right arrow and the infinity. Okay, rho I approaches infinity, and exponential minus C times rho I minus exponential minus C dot. Okay, I need to find the dot. Okay, minus C dot 0. Okay, so it is equal to 1 over rho bar I times 1 over minus C and times 0 minus 1. Okay, like this. And it is equal to it is equal to 1 over rho bar I times C. And we substituting C, okay, in here, into here. Okay, then we have a 1 over rho bar I. Okay, it is 25 minutes. Let us take a break.